Hello friends, welcome to Susan and John MapTube. In this video, we're going to learn about classification of second order partial differential equation. And in the coming videos, we will learn how to solve a second order partial differential equation. And later, we will learn the most important part, that is how to model real life scenarios using partial differential equation. And obviously, we will learn how to solve such partial differential equation. Anyway, before we start, get connected with us and let's start. So, a general second order partial differential equation will look like AUXX plus BUXY plus CUYY plus etc. which you see in the screen. These A, B, C, etc. can be numbers or variables. Depends on the model. Okay, and I hope you remember UX, UY, etc. The partial derivatives which you learned in your second semester. UX means you're differentiating a function with respect to x. That means you ignore all the other letters and you treat x as the only variable. Now, in this video, we will focus only on classification. Anyway, a second order differential equation is classified as elliptic or parabolic or hyperbolic. Now, wait a minute. We are learning application of partial differential equation and we are going to learn how to model many real life stuff into partial differential equation. So before we start, we have to be very clear with why, and the third one, what. So the first question, why do we need differential equation? Okay, I want you to pause this video for a moment and think about one thing. When did you learn about differential equation? Most probably, your brain will go to your plus 2 or your high school when you learn physics. In physics, you started talking about dynamic system. Or maybe in economics, you're talking about dynamic system. That means something which moves with respect to time or something which changes with respect to temperature or something which moves with respect to another variable. And whenever you have a rate of change, immediately our brain tells us you can convert it into the derivative. So look at this. If the price of a commodity is changing with respect to time, my brain tells me dp by dt is proportional to the initial price. Or maybe if the quality of a food item becomes better or horrible or whatever with respect to temperature, then I can write dq by d temperature is proportional to something something. And this is how we ended up with basic differential equation. And later in mathematics, you learn so many techniques. In your first semester, in your second semester, you learn so many techniques how to solve differential equation. Because differential equation gives us the model in terms of rate of change, not the actual value of the price or the function. So once you solve it, we are able to understand the true equation. Okay, now let's jump to partial differential equation. Now think practically. When you think about a wave motion or anything in 3 dimension, then you will understand the models actually depend on more than one variable. I'll give you a very simple example. The mark of a student depends on the time they spend for academic activity. And it also depends on the rating of the university. And it also depends on the financial condition of the student. And there might be many other factors. So can you see the mark of a student is a multivariable function. Now, if I am talking about how the mark changes only with respect to time, that will be a partial derivative. So when I model this, I will end up with a partial differential equation. Anyway, we are talking about a second order partial differential equation. Okay, now the question is, what is the use of classification? It is very easy. What we do is we focus only on the second order part. Can you see the part I kept in the box? And we will calculate the discriminant b square minus 4ac. Now, imagine the discriminant is equal to 0. Then very simple, for your examination you just write parabolic, you may get full mark, maybe 2 out of 2 mark. And maybe they won't even ask. But this is very important, because when you see that the differential equation is parabolic, we can understand we are talking about models which comes under the classification of diffusion. And diffusion means, imagine you take one bucket of water and add some colors and don't do anything. You'll see the colors will slowly diffuse into it. Or you can think about, like what you call, we take one cup of hot coffee and you keep it for some time. Initially, there will be heat transfer. Of course, the what you call heat will the it will move from hot body to the cold body, the surroundings, and after some time it will attain steady state. So that movement, that is a diffusion which is given by the parabolic equation, and after some time the temperature will be equal to the surrounding temperature, so it will be in equilibrium. And if a system is in equilibrium, it will be an elliptic model and the discriminant will be less than 0. So once more I'll repeat, we calculate the discriminant. If the discriminant is 0, we understand it is a parabolic model, or we can understand the actual model is about diffusion. Or like what you call, you can imagine, you keep a heater in the room, and initially you'll feel the heat transfer, and after some time the whole room will come into a steady state. So that diffusion part is given by parabolic model and the steady state is given by the elliptic model. Now imagine delta is, what do you call, greater than 0. Just imagine the delta value comes greater than 0, and immediately I am able to understand it is hyperbolic, and it means we are talking about wave type of model. Did you get the point? We are talking about wave type of model. For example, if I pluck a guitar string, it will keep on moving. The movement of sound waves in air, or a ringing bell, or in stadium, have you seen people will keep on forming wave. The people are not moving, but people will stand up and then sit down and stand up and sit down. Such movements are given by hyperbolic. So one last time, if delta equal to 0, it is all about diffusion, and delta less than 0, it is elliptic and it is about steady state. For example, the gravitational potential. Come on, think about it. Our solar system, as far as we know, is in a what you call fixed in an equilibrium gravitational potential. That is why we keep on observing similar things every time. So that steady state, if it is dynamic, we cannot live like this. So that steady state is given by elliptic equations. And if it is greater than 0, we call it hyperbolic. And if it is hyperbolic, we are talking about wave motion. Okay, that's more than enough. Now let's start with problems. So the first question, please write. Classify the following equation. So the first question is 5uxx minus 2uxy plus 3uyy equal to 0. Point number 1, it is a second order differential equation. And what I do is, I'm going to classify by discriminant. What is the formula for discriminant? B square minus 4ac. I can see a is 5, b is minus 2, c is 3. So minus 2 the whole square minus 4 times 5 times 3. And that is equal to minus 56 less than 0. Classified, it is an elliptic equation. But remember, the point is not about writing elliptic. You have to understand. When we solve this equation, we will get a model. And that is a real life model which we are going to control. But even before solving, later when you learn, you'll understand solving an equation will take a long time. It's a long process. It might take 3-4 pages of calculation. But even before solving, I'm able to get a clear idea about the model. So since it is an elliptic equation, I can understand it is in equilibrium. Can you see? I'll show you one thing. So look at this. This is exactly the question that I showed you. So this is an elliptic model. Can you see? You can see the part of an ellipse. At the same time, this is the question we are going to do next. This is a parabolic model. And what do you understand when you see the parabolic model? Come on, think about it. I told you a few times. And this is the hyperbolic model, or we call it the saddle. Can you see? The seat of a horse. It is kind of like a saddle. Are you able to see the saddle? So this is hyperbolic model. Okay, let's go back to the main part. So question number 2. Classify the equation 4uxx plus 12uxy plus 9uyy equal to 0. Very simple. Delta equal to b square minus 4ac. I got the value 0 and immediately my brain tells me it is a parabolic model. And now I can understand very clearly, okay, we are talking about diffusion. This is the model which talks about diffusion. Okay, now another question. Please write the question and I want you to do it yourself. 7uxx minus uxy minus 2uxyy plus 5ux minus 3u equal to 0. Okay, in examination, don't get confused. We do not care about the lower order derivatives or the function, etc. We focus only here. So when you calculate the discriminant, don't get worried about these things. You just focus on this. So minus on the whole square, minus 4 into 7 times minus 2, which I got as 57, greater than 0. Come on, tell me, what do you mean by greater than 0? Hyperbolic. So the main point is, once more I'll repeat, in examination you do this much, they might give you 1 mark or maybe 2 mark or maybe 4 mark, whatever. But the main point is, when you learn an application, you should be aware of what you are doing. So you saw the saddle. Just now I showed you the graph. It's a saddle. And immediately your brain should tell, okay, the model is about wave or signal propagation or some information which tends to travel in one direction. Okay, that means oscillation. Okay, now let's do some difficult questions in this. So write the next question. Classify the equation. Now I'm going to make your life a little bit difficult. So classify the equation x square into uxx plus 2uxy plus uyy equal to 0. So the only difference is, to make the equation look colorful, I kept some variable. So our answer will be conditional answer. Okay, anyway, let's calculate the discriminant. B square minus 4 into x square into 1. I get this. Now I'm going to write like this. If discriminant is positive, it's hyperbolic. So 4 minus 4x square greater than 0. So 4 is greater than 4x square. That means 1 greater than x square. That means x square less than 1. And in your plus 1 plus 2 you learn about modulus and squaring function. This can be converted into minus 1 less than x less than 1. You can check your plus 2 book, or you can talk about the modulus function. If x square is less than 1, then the x value should be between minus 1 and 1. So my conclusion is, you plug in any x value between -1 and 1, it will be a wave model. That means hyperbolic. Now, if discriminant is equal to 0, that means 4 minus 4x square equal to 0, which gives me x equal to plus minus 1. So when you plug in x equal to 1 or minus 1, the equation will be parabolic. And what do you mean by parabolic? Diffusion. And the last one is obvious. You put delta what do you call, less than 0. So 4 minus 4x square less than 0. So 1 less than x square, or x square bigger than 1, which means the other part. X is less than -1 or x is bigger than 1, we get elliptic. And what do you mean by elliptic? Okay, I'm not going to talk about it. You tell me. Okay, now let's go for the next question. Question number 5. uxx plus y square into uxy minus uyy equal to 0. Come on, this is a second order differential equation and it is a variable equation. Everything depends on the value of y. Discriminant is obviously b square minus 4 times 1 times minus 1, which is y square plus 4. That's great. Because this value will never ever become 0. Come on, being a variable, y can be anything. But when you square it, it has to be a number bigger than or equal to 0. And when you add plus 4, it has to be a number bigger than 0. That means this is 100% greater than 0, hyperbolic wave propagation. Now let's go for the last question, that is extra important. So classify the equation x plus 1 uxx minus 4 uxy plus x minus 2 times uyy. Okay, I wanted to pause the video and calculate the discriminant. Anyway, I simplified and I got the answer minus 4 x minus 3 into x plus 2. Maybe you got a quadratic or something. Anyway, I wanted to simplify and I wanted to comment below whether you got the same thing or not. Come on, try it. And after this, okay, do you know method of intervals? Method of intervals is a simple technique. So what we do is, there are three possibilities. So obviously discriminant will be 0 if x equal to 3 or x equal to minus 2. So what I do is, I'm equating the discriminant to 0. I got 3 and minus 2. Now I want to know what will happen if I plug in bigger values. I mean bigger than 3. For example, I can keep 10, I can keep 20, I can keep 3.1. Anyway, I'm going to keep 10. So negative 4 times positive. So I'm 100% sure our answer will be negative. You keep any number bigger than 3, our answer will be less than 0. Negative means less than 0. Now if I keep any number between minus 2 and 3, come on, I'm going to take the easiest number, obviously 0. So minus 4 into minus 3 into 2. Oh, it's going to be greater than 0, positive. And I can keep any number less than minus 2. You keep any number, it is going to be negative. I already tried it. Oh, now I can understand very clearly. If delta equal to 0, x will be 3 or minus 2. That means when x equal to 3 or minus 2 in this equation, it is parabolic. And if delta is less than 0, from the picture I can understand x has to be a number bigger than 3 and x has to be a number less than minus 2. Or you can keep any number bigger than 3 or you can keep any number less than minus 2. You will get delta less than 0. Similarly, you keep a number less than between 2 and 3, you will get positive. So remember, in this video, what we learned is what is a second order equation. Then we learned the importance of hyperbolic, parabolic and elliptic. And finally, there are two types of problem. One, the coefficients are numbers And second one, the coefficients are variables and our answer will be conditional. I'll be back with more videos like this. So till then, my friends, bye.